So again, lesson 4.7, linear and non-linear functions is the topic for today. The date is 2/29/16. So let's first start with what we know. Let's start with a linear function. That's what we spent the majority of this section and even last chapter about. So what is unusual about a linear function when you graph it? What do you get? Sean? Okay. So the graph of a linear function is a line. Okay? All right. So let's talk about, well, what did those functions look like? What kind of form were they written in? So that when you saw it, you go, oh, I know I'm going to get a line. How did they write the equations? So if you did the extra credit, I think the first question was like that. Yeah, so what we're going to be paying attention to is this notion of slope-intercept form. If the line isn't written that way, can we get it into that form? And if we can, then that means we know we're going to get a line. So can somebody tell me what slope-intercept form looks like? How would you write that? Sean? Okay, good. So let's explore the m. What's the m called? It's called the slope. That's why it's called slope-intercept form. Now, we also studied slope by a different name. And it kind of came up a little bit more in this chapter. And it came up in the very, very beginning of the Unit 3. So what was another way of saying slope? Desi. Okay, now you're missing a word. I agree. But it's not just rate of change. There's something about that rate of change that made it a slope. Do you remember, Ashley? It's also called a constant rate of change. So one of the things that you did was to determine whether you could get a line from a table of values by checking to see if there was a constant rate of change. If there wasn't a constant rate of change, then we weren't going to get a line, and we just kind of left it alone. Now we're going to kind of talk about that. So let's look at a set of values and prove that we would get a line from that set of values without graphing it. So we've got the ordered pairs 250, 435, 620, and 85. So what I'm going to do is look at the rate of change in my x's, and then I'm going to look at the rate of change in my y's, and then I'm going to put them together like slope to see if it's a constant rate of change. If I have a constant rate of change, I'm going to get a line, because that's the definition, the alter ego for slope is constant rate of change. So help me out here. What do I do to 2 to get to 4?
Plus 2.
Okay, add 2. What do I do to 4 to get to 6?
Add 2.
I add 2. How about 6 to 8?
Add 2.
Okay, so if you notice, the x's were constant, but that's not enough to say I'm going to get a constant rate of change. I now need to check out my y's. What do I do to get from 50 to 35? Subtract 15. Oops. How about from 35 to 20?
Subtract 15.
Subtract 15. And from 20 to 5?
Subtract 15.
I subtract, oops, sorry, whoa. I subtract 15. So if I want to look at that rate of change, remember it's the change in y over the change in x. So we get negative 15 over 2 for the first one. We get negative 15 over 2 for the next pair of points. Oops, sorry, that's supposed to be blue. And then we got negative 15 over 2 in the third pairing of points. And what do I notice about negative 15 over 2, negative 15 over 2, negative 15 over 2? They're all the same. So because I have a constant rate of change, that leads me to conclude that I'm going to get a line for the graph which allows me to conclude that this is a linear function. Okay, so we've figured out how to get a line. So I guess my question would be, what would be different in my table for me to get a non-linear function?
And dollar would have to be different for say like 15 minus 45. And you'd be like,
So you're saying in our chart that this difference from one y to the next may not be the same, okay?
or that one.
Or it could be here, okay? Could I have one of them that's the same and the other one that's different? Is that allowed? Would that give us a constant rate of change or not constant? All right. Okay, so let's check it out. That sounds like a good hypothesis. Let's see if he's got something going on. So let me go back to regular. So let's look at this set of ordered pairs. Let's see, 1, 1, 4, 16, 7, 49, 10, 100. And let's do exactly the same thing that we did before. So what do I do to get from 1 to 4? I add 3. From 4 to 7? Add 3. To get from 7 to 10? Oh, that looks pretty constant. All right, let's check out what happened on the other side. Shh, boys. So what do I do to get from 1 to 16? Add 15. Remember, you got to have an operation there. How about from 16 to 49? Excuse me.
33?
Yeah. Add 33, it is increasing. And what about from 49 to 100?
51.
I would add 51. So if I wanted to look at the rate of change, which would be the change in y over the change in x, I've got 15 over 3. I've got 33 over 3. I've got 51 over 3. Now all of these I could simplify those fractions down, which might make things a little easier. So I end up getting 5, 11, 17. So what's true about 5 compared to 11 compared to 17? Are they the same or not the same?
Not the same.
Okay, so we would say not equals. So what we have here is no constant rate of change. Because we have no constant rate of change, then it's not linear.
What does that say?
No constant rate of change, not linear. No, it's an N.
Oh.
So if something's not linear, then what do we call it? Paul? We call it non-linear. So a non-linear function is simply any function where there is not a constant rate of change. So let's see what this graph would look like, just to verify that it's not linear. Because if it's linear, I should get a line. So let's see, this set of numbers, I'm going to go up to 100. So let's see, 90, 80, 70, 60, 50, 40, 30, 20, 10. Let me actually go this way. Notice all my numbers are positive, which is kind of nice. And here I'm going to go up to 10. 2, 3, 4, 5. Oops, those are lousy looking. 4, 5, 6, 7, 8, 9, 10. So this is your X, this is your Y. We have 2, 4, 6, 8, 10. And for our purposes, we're going to count by tens. So this is 20, 40. Now, by the way, this graph should be in your notes. You shouldn't be just observing. 80, and there's 100. So let's see, 1, 1. Ooh, yikes. That first tick mark on the vertical is 10, so 1 would be really low. So I'm going to put it just right there so you can see that it's above the x-axis. Then we went to 4, and we went to 16. Well, if this is 10, the first mark, halfway would be 15, so a little bit more than halfway. And then it went to 7, and 49 is just below 50, so somewhere around there. And then 10 goes up to 100. So notice that I can't draw one straight line. In fact, if I try to connect, I could get lines through those two, lines through those two, maybe lines through those, but I can't get one straight line between all of them. So really the graph for this one what would be a word that you would use to describe that graph?
Nonlinear.
Okay. Now that's what it is, but I want to come up with a word that describes what we're going to get. Nonlinear is not a good one because we want to be more specific to what kind of shape do we get? What kind of thing? Because it's not a line, it's got to be it's curved somehow, right? So what we're going to see is curves. Now these curves can come in all sorts of different shapes and forms, okay? So one of the biggest things you're going to be asked to do tonight is look at a table of values and answer whether it's linear or it's nonlinear. And the easiest way to do it is to not graph it. The easiest way is going to be to simply look at the rate of change. Is there a constant one versus is there not? So I've got two examples for you guys to work on. The directions say determine if each table represents a linear or nonlinear function, and then explain. So the first one we've got, and instead of writing the functions vertically, we're writing them horizontally, so you practice with that. We have our ordered pairs of 0, 20, 5, 16, 10, 12, 15, 8 in the first one. Second one, our ordered pairs are 0, 0, 2, 2, 4, 8, 6, 18. So what I'd like you to do, without graphing, check out the rate of change and see if you have a constant one or a not constant one. When you explain, something about that rate of change is going to be part of your explanation, whether you determine you have a linear function or a nonlinear function. Okay, so I'm going to go ahead and look at the first one. What do I do to get from 0 to 5?
5.
Add 5. You got to give me an operation from 5 to 10.
Add 5.
And from 10 to 15.
Add 5.
Okay, does that mean in itself that I've got a constant rate of change? No, I got to check out both parts in order to conclude that. So what do I do on my y's from 20 to 16? So minus 4. How about from 16 to 12?
Subtract 4.
How about from 12 to 8?
Subtract 4.
So remember how this works. We're looking at the change in the y over the change in the x. In each of our cases, our y was a negative 4. Oops, wrong color. Interesting, 5/4, huh? I see a negative 4. I see a negative 4 on my y. I see a negative 4 on my y. Changing in my x's. I see a positive 5. a positive 5, a positive 5. So what I noticed is all of those are exactly the same. Now, some of you told me 5/4. How did I get negative 4/5 and you told me negative 5/4? Kyler.
It's because you subtract 4, and the y is always on top. So.
Yeah, that's the key right there, is don't get just, oh, the number on top goes on top in my fraction. You got to make sure that it's y's over x's, okay? So we could conclude this is a linear function since there is a constant rate of change of negative 4/5. Now, honestly, if you wrote negative 5/4 on a test, I could not give you full credit because you did not have the right constant rate of change. So be cautious with that. Now, the book also explains it slightly differently. Instead of writing it as the constant rate of change as negative 4/5, what they said, and this is an option for you guys, is as y increases, or in this case decreases, by 4, x increases by 5. So instead of writing the rate of change as a slope value, what we're used to doing, they broke it down into what happened to the y versus what happened to the x. So that's your option. You can do that. Sean?
Well, we have to write this in our homework by negative 4/5 equals to
If the directions say explain, then you have to give me some sort of support. Okay? All right, let's try the next one. Not everybody had finished when we were asking questions. What do I do to get from 0 to 2?
Plus 2.
From 2 to 4?
Plus 2.
From 4 to 6? What am I going to do to get from 0 to 2?
Plus 2.
How about from 2 to 8?
4.
Plus
6.
6, not 4. From 8 to 18? So what we want to do is compare this one, the difference in the y's over the difference in the x's. No, I don't put it equals. And we're going to create 3 ratios or rates, and then we'll check them out. So in the numerator, there was a 2, a 6, and a 10. In my denominator, there was a 2, a 2, and a 2. So what I can do is check those all out, and that gives me 1, 3, 5. Since those are not equal to each other, we can conclude we have a nonlinear function. So there's a nonlinear function since there is no constant rate of change. Okay. If you wanted to be even more specific, you would say in the first 2 order pairs there was a 1-to-1 change. The next it was a 3-to-1. The next it was a 5-to-1 change. Okay, Bria.
I have a question. Like when you're writing in the grade
Mhm.
about how the book says it,
Mm-hmm.
if you wrote it like that, would you have to say if it's linear or not?
Oh, you always have to tell me. That's the first thing you tell me. And then you support it, either what I wrote in black, since there is a constant rate of change of negative 4/5, or it's a linear function since as y decreased by 4, x increases by 5. That would be the other way to do it. Okay? All right, so I know a lot of you wanted to do graphing. I'm going to give you the opportunity to graph. So we're going to graph on the last one, and the directions say graph to determine if the function is linear or nonlinear. Linear or nonlinear? Talia, let's not do that. So we're going to do an interesting one. Y equals x squared plus 1. If you did the extra credit, you'd recognize an equation similar to that you worked on. Now, because this isn't linear looking, it doesn't go in y equals mx plus b form, because this doesn't have an x, it has an x squared. In order for me to test this out, I can't just use the y-intercept and the slope. So what I have to do is come up with a table of values. So I'm going to do my table of values. Remember, the second column is where you're going to actually do calculations, and the result will go into the third column. Then the first and third column become your ordered pairs. So I'm going to pick my favorite points, -1, 0, 1, 2, and I'm going to test them out. So -1 squared plus 1, what's -1 times itself?
1.
So I get 1 plus 1 is 2. Okay, let's try 0. 0 squared is 0, plus 1 is 1. Okay, that's nice. 1 squared plus 1. What's 1 squared? 1. What's 1 plus 1?
2.
Oh, that's kind of weird. I ended up getting the same y value, but at different x values. The numbers were similar, except for their signs were different. Huh. All right, 2 squared plus 1. What's 2 squared?
4.
Oops, sorry. Don't worry about it. 4 plus 1 is? 5. So, okay. I'm going to try something. I'm going to add one more number here. What would I get if I plugged in -2? What's -2 squared? Positive. Negative times a negative is a positive 4. And 4 plus 1 is? 5. Okay, you don't really need to shout. So I need to go up as high as 5. 3, 2, 1. And I need to go right and left 2. So again, I always kind of cater my graphs to my numbers. Here's x, here's y. 2, 2, 4, 6, -2. And then I'm going to graph those points. So -1, 2, 0, 1, 1, 2, 2, 5, -2, 5. So again, I couldn't draw lines between these, and from one side to the other is how we graph. Definitely am not getting a line. So based on that graph, I can tell that I have a nonlinear function. And the explanation would be nonlinear functions since the graph is not a line. Since the graph is not a line. So homework tonight is going to ask you to look at a table and tell whether you have a function or not a function, if it's linear or nonlinear. Sometimes they're going to give you a situation, but they tend to always give you a table. Graphing is not always the best. And then sometimes they will ask you to graph a function, and you're going to pick your x values. Again, I would stick with the same 4, and you could add one more if you wanted to, like we did, and then check it out. So your homework is off of page 330, 1 through 3, 331 to 332, 1 through 6, 8, and 12, and you have the rest of the period to work on that.